Hey everyone, welcome back. This is Al from Scape It, back with another episode of Dev Time. Today I think we are going to look into accessing the contents of folders on your hard drive from the game, from the code. This is because I want to expand the save system of Skald a little bit. If you've played the demo, you know that Skald only has a single save file. For instance, you can save, and then when you load, you just load from where you saved. There is no choosing between save files and having multiple saves. Originally, I actually considered having this as a feature in the game, having only one save file that you could save pretty much anywhere, but you could only have one save at any given time. But a major design pillar of Skald is that I don't really want I want the game to really respect players' time. And this isn't a roguelike, it's nothing like a roguelike, it's a role-playing game, and I think people will appreciate the convenience of having multiple save files. So one way of going about it is instead of having it like this, where there is really no save menu, we could do something like this, where when we save, there is a file, there is a menu, and we can choose between different save files. So for instance, we could choose to save here, and if we then choose to go back and load, then there is a save here. We could choose between different save files. And so this is still pretty primitive, but it's a lot more, it's a lot further down the line than it used to be. And most importantly, it's very expandable. This is just mainly a question of interface and expanding the interface and making it more detailed and so forth. But in essence, this is what we want to do. And one of the most important things, one of the first things we have to implement in the class that I have that controls saving, that I don't have right now, is a function to list the content of the save folder. We will see it here, for instance. Here we see the two saves, quick save and save 2, something that lists the content of this folder and then allows us to choose between the files in that folder and manipulate them and so forth. So tag along and we will see what we can do. Okay, so here we are in the save control, which is a static class that basically organizes taking data from the game and packing it into files on the hard drive. I'm not really going to go into very much detail on how we do it. Suffice it to say, we do it through serializing game objects and then converting them to DAT files full of strings on the hard drive that we place in a saves folder. I'm going to do a quick overview of just the workflow of saving. So if you want to skip it, you can skip a little bit ahead. It's probably not important, but I'm also not going to go into so much depth that you can basically build your own saving system just by watching this video. I'll probably do one later if you want to. So just leave a comment if you want to know more about how I save data in my game. But to do a quick overview, there is a function there is a static class called save control. It's called save control. It has a function that allows you to save the game, and what it does is that it takes as an input something called a save data container, which is basically just an object that it can basically be any kind of object, but you have to mark it as serializable like this. This means that it will allow the system to convert the bits and bytes that the object occupies in memory when you are running your application, that it will allow the system to take those bytes and convert them those bits, and convert them into a string, and then you can use that string to put it onto a file and so forth. And the nice thing about it is that you can run this in reverse as well, where you take the string you created and then you can turn it back into bits and put it back into memory, and then have the game object up and running like nothing. So for instance, you can this save data container could contain anything. I could put anything inside it. Right now it's just empty, but I could make an implementation of it that takes, for instance, a player character, and the player character could then be serialized, turned into a string, and loaded onto a file on the hard drive. It would end up looking something like this here, one of the save files, and then I could run the whole process exactly like that, just in reverse, when I want to pull the object back out again, and then I could sort of put it back into the flow of the system, so it appears on screen in the game. And that's exactly what I do when I save and when I load. When I save, I take all of the important objects like the characters and the party, all the inventories, the maps and so forth, and I turn them just into these huge piles of string, and then I store it onto a file on the hard drive and save them that way, and then I run the whole process in reverse when I load it back up again. It's pretty neat. I'm not sure if I will put this exact code here up on GitHub. I probably could, but I would like to look over it a few extra times. But if someone out there really needs it, if you need help with saving, I could definitely put the code up there, and you could have a look at it. Just let me know in the comments below and we'll work something out. No problem. Okay, so the thing that's missing right now, the way it's working right now is that when you call the save function from one of the states in the game, it will just assign the file name quicksave to the save file, and whenever you try to load, it will also always load the file name quicksave. This function takes different file names as a parameter, but I've not really implemented that for now. So the way it's been working up to now is that even though the system has capacity to make multiple files, I haven't really made it that way, and that's mostly because I don't really have a menu system for choosing between files. So that's actually what we're going to build now. The first component we need, or pretty much the most important component we need to build that menu system, is to have to have a method inside this class that interrogates the path where we save the files to, where we save our save games, and then sees, okay, what are the files in this directory? And then it gives us a list of those files. That would prove the basis for making a menu where we could choose between those files. So that's actually exactly what we're going to do now. We're going to take something that looks in the save path that we put all our save files in, which is this folder. There is now currently 2 files there. I've cheated a little bit and created a second file just for the example later. And then it will look in this folder and print the files that are in this folder. So it will allow us to make a menu from there. I think the first thing we're going to do is we are going to start by making a method here. We will make it static. This whole class is static for now. I might make it not static later, but that will be an adventure for another time. And it will return, have as its return value a list of strings, and those strings will be the names of the files in the save directory. Let's call it get save path content, perhaps. Okay. So the first thing we need is to get the path to the folder. The path isn't here in the it could be just a string variable floating around in the class, but I don't want that for one simple reason. When you install the game on a new computer, it won't automatically create a folder for the saves. So if we just had a path that led to this folder, we could end up in a position where we investigated the folder without the folder existing. So to get around that, I have a get function down here. That is pretty much the only way to get the save path from inside this class. And we use the constant application persistent data path. This is built into Unity, and this is where this changes depending on the system you're using. So for instance, if you're using Windows, it will be in the app data folder. If you're using Mac, I have no idea where it will put it, but it'll put it somewhere else. And then it depends. We append the saves part to indicate that there is actually a folder called saves. So for me, this is pretty much the string. This is the path where all of the data for the game is being kept when I install it on my computer. And this folder right here, saves, isn't necessarily here when we start the game. So to ensure that it's always there, we both build the path, and then we use this directory info. We could call it DI is not bad. Let's just call it directory instead. And we create a directory that is basically this save path. This might seem redundant, but this line of code doesn't really do anything if we don't if there is already a folder in the save path. We could probably even do this, come to think about it. I actually think this is good enough. Yeah, this is enough. So it doesn't really tax the system very much, and it ensures us that whenever we need the save path, not only will we have like the string to the save path, but we will also ensure that there is actually a folder constructed where the save path would be. So just keep that in mind. So in the get save path content, since we are referring several times to the save path, we will just do this. I can't type today apparently. And refer to our get save path method like this. And so now we can safely refer to this local variable. That's no problem, since we already know that the local variable stems from this function. And then we will also create a list to contain our result. Whoops. List of strings. Let's call it output list. Like so. This is where we will put all our results into, and we will return it on the end of the function. So let's just write the return function right away. The return line right away. There we go. And now something has to happen in between here. So like we saw earlier, the directory class here, it's very handy when it comes to examining directories, naturally enough. It's part of the systems.io namespace, so you have to be using that. But let's just refer to it. Directory, and it has a method called getFiles. And getFiles takes a path as one of its parameters, and then it returns an array of strings with the paths, with all the paths of all the files that are in that directory. So let's just give it the save path, like so. And but this isn't exactly what we're going for, because this is just an array of strings. I want it to return a list of strings. So what we're going to do is that we're going to build this into a for each loop, like this and this. String, let's just call them file, and so it will loop through the results, and for each entry into this array, we will move it from the array into the output list. So we will just do output list dot add the file. This might seem a bit redundant, but we will see later why it's a good idea. And for now, we have to do some. We later have to do some modifications to these strings, because they will be longer than we need them to be. But let's just write a small debug function now, so we can actually try and examine the folder content. Let's just do. This can just be a private static string, just a little string builder. Let's call it print save path content, like so, and we will make a results variable, and then we will make another for each loop, basically the same as before, but this time we will refer directly to the get save path content instead. And then for each entry, we will append it to the result. I'll just finish and then I'll explain. So this is a very simple little function that we can connect to, for instance, the saving function down here. What it will do is it will basically run this method. It will look in the folder, make a list of all the file names in that folder, and then it will take that list and it will just make it into a big string instead of a list. And the good thing about that is that it's a lot easier to print in the debug window in Unity. So we could probably also just do this debug dot and log the result, and then we could try and call this function from the game save function. So whenever we save the game now, we will get a debug message that the game has been saved, and then we will also get a debug message in the debug window in Unity that we have that lists the current content of the save folder, of this folder. So let's also just for fun, let's create another save file just by copying it here directly in the folder, so we can see that we have, hopefully when we save next time, we will see that we have 3 different save files in the folder. Okay, so from the game, let's just press F1, which is the quick save button, and we will see here, okay, we saved, and underneath here, it lists the full path of all of the 3 files that we were looking for that was currently in the save folder. So it seems to work pretty well. Now let's do some modifications, because for our purposes, we don't want the full path like this. This entire portion here is just the save path, and we already have a function in our game to tell us about it. And we also don't need to know that it's a .dat file, because that is also part of the save function. What we're really interested in is just the name of the file, this little portion here. So we're going to clean out the portions we don't want before we move on. Let's go back here a little bit and see. We are here. So what we can do is we can take, let's just make a local variable called s, and we will first take file, and we can just do a a replace, where we replace all instances of the save path with just nothing. And the save path, as we remember, is the first half of this. Oh, all of this is the save path. All of this actually is the save path. So the first, we are replacing all of this with just nothing. And then we do it again. The exact same thing. We take the string that we have so far, and then instead of replacing the save path, we replace the file type, because the file type is the .at part of the path that we append to all of the save file names. So if we do this now, let's save, and yeah, of course we have to make sure that we don't really that we actually use the updated string. We actually refer to the string s now. This should work. So it lists all of the content in the folder. It goes through that list, takes each entry, replaces the save path and the file type, and then pushes it from the array into the output list, and then eventually it returns the output list. Let's see if it works. Okay, let's see now if it works. Let's press F1 to quick save and investigate this. Now we have just the file names. Just the file names, just these. And that's exactly what we're looking for. Okay, there you have it. Looking over these functions now, I don't think there's much I would change. I would love to hear if there is something you would do different. I'm fairly certain that saving and encoding, decoding, encrypting, and so forth, even in games, is a pretty big subject, and I'm only scratching the surface of it. So if you have any tips or questions, I would love to hear them. Just put them in the comment. I read everything, and I try to get back to everyone. Please subscribe if you haven't already, and be sure to check out the devlog. So you can stay posted on the Skald project, and I will be back with another video where we continue this developing the save menu system in a couple of days. So until then, have a great evening, and goodbye.